All right, so quick look here. So here's some examples of some questions, this kind of stuff that you're going to see on the final, or not the final, the test. So this test is not very algebraic, right? There's not really that much stuff to do. On the first test, the first review, there was a little more to do, I think, in terms of algebra. You had to simplify some limits with rational functions and complex fractions. But on this part, it's mostly just, there's a little bit of algebra, but it's mostly just knowing the theory behind all this stuff, right? So what's the theory tell us here? The limit of f of x as x approaches infinity and negative infinity. What are we going to get for this one? Here's the function. Talk to me about infinite limits here. Limits at infinity. Top is higher degree than the bottom, right? And so you know, is this going to have an asymptote? A horizontal asymptote? No. Okay, it actually does have a slant asymptote of some kind, right? But I'm going to hold off on the slant asymptotes until later. We're not even going to do them on this test. We'll get back to all this stuff in the future, and I just don't want to spend time on that right now. Okay, giving you stuff to work on with that. So what do we know here? What's the limit as x approaches positive infinity? Top is bigger than the bottom. So what's that tell you?
Has some kind of asymptote.
No. It's going to infinity. Right, but which kind? Positive, because I'm putting in a positive value for x, so I'm going to get a positive term divided by a positive term. So I'm going to get infinity, right? What about when x approaches negative infinity? Everybody agree it's going to be negative infinity? I know it's going to be infinite, because if I'm plugging in an infinite number, top is higher degree than the bottom. But what's the sign of the top term going to be? 41 times a negative number to the fifth is negative. 19 times a negative number to the fourth is positive. Negative over positive is negative, right? So as a consequence, this doesn't have any horizontal asymptote, right? Make sense? Okay. This is an easy one, right? As x approaches 6 from the left, what do we get? 7 over 0 and 8, right? I agree.
Yeah.
I'm getting a number slightly less than 6 minus 6 is a 0 minus. I got a 0 on the bottom, so it's infinite. I get positive over negative is negative. Okay, no biggie. Okay, in this one, you got to classify, find any discontinuities, and then classify them as removable or non-removable. Just one of many different kinds of problems you could get. So, talk to me about where would a discontinuity be located? Let's see hands. What do you think? Yes, sir. X equals 3. No other place, right? There's nothing, both pieces of the function are fine by themselves, right? It's only at the junction where they may or may not join up. So that's what we'd have to investigate. How would we know if there's a discontinuity there? Well, there definitely is a discontinuity, isn't there? How do we know right away? Yeah, the function's not defined at 3. So there is a discontinuity at 3. So discontinuity at x equals 3, for sure. Is it removable or non-removable? How would we know? What's it mean? Maisie, what's removable?
Just
1 point. I can either redefine or add or define a value at that 1 point and fill in the hole, and it works. If it's non-removable, what's that mean? It's non-removable.
An entire piece of the function has to be
Okay, so an infinite number of points would have to be redefined. Could be an asymptote, could be just a gap in the function, right? So how would we know? What are we going to do here? What do you think? Brian, what are we gonna do? If I want to determine if this is removable or non-removable at 3, what would I have to do?
As X approaches 3 for each side.
Perfect. So we could do the limit of f of x as x approaches 3 from the left, and I'd get what? 2, because I'd be using the top part, right? I'd do the limit of f of x as x approaches 3 from the right, and what am I going to get? 2. So what's the rule here then? The limits are the same, right? So is this discontinuity removable or non-removable? Can be removable. Good, because I'm only missing just that one value, right? If we were to graph it, it would look something like, it's going to look something like this. I think I did it backwards. I did. It looks something like this, right? Right? They meet up, but the function's just not defined in 3. Okay. What if we did something like this? What if that were included there? Would the function be continuous? Everybody agree? If I did that, that would fill in that dot, and yeah, it would be continuous. Now I could graph this without taking my pen off the board, right? Okay. Okay, what about this one? Where is this function discontinuous, if anywhere? You got an idea? No? Where's it gonna be? No, we're making it harder than it needs to be. How come? Okay, and if we look at this thing, where is the function discontinuous? It's just discontinuous where I'm either going to, if there's a piecewise function, yeah, in like the last example, but that's not going on here, right? This is just a regular, it's not a piecewise function. Only where we're dividing by 0, we're taking an even root of a negative number, would this thing be undefined, right? So if I look up here, that's fine. I'm multiplying x times something, no problem. That's in the numerator. Cosine is fine by itself, right? Cosine is continuous everywhere. But inside the cosine, I do see one example of where there is an x on the bottom of a fraction. And I simply, doesn't matter where it is in the function, I can never divide by 0. So we know that x can't equal 0. So it is discontinuous, right? Now, what's going on here at 0, though, is the question, I guess. Is this going to be a removable or a non-removable discontinuity? Why? Okay, you're right. How come it's a whole, though? That's pretty good. How come? Okay. So if it's a whole,
Oh, we wrote it. Oh, because cosine won't have any asymptote, right?
Right.
Continuous.
Right.
They're just not one.
Okay, so cosine, the output of cosine, and it is going to be like, if that x were not there, this would be a non-removable discontinuity, right? Everybody see that? Because think about what would be happening to cosine. Actually, no, it wouldn't. We'd actually be fine. We'd actually be fine, because 1 over x squared would go to 0, right? And you'd end up with 1 over x squared plus pi halves, which would just go to the cosine of pi halves, which is what, 0, right? Does that make sense? Okay, so even if that x weren't there, this one would be fine. Okay. What if I did something like this, though? What if we didn't include, I'm going to change this just a little bit. What if I took this pi halves out of there? Okay. Now if the x were gone, right? If the x were gone out in front, Now I've got the cosine of 1 over x squared. As x approaches 0, what does 1 over x squared approach? As x approaches 0, because that's our problem, right? What does 1 over x approach? Infinity, right? So this is one of those bizarre oscillating behavior ones, where if I didn't have that x out front, this would look like a cosine curve that would just go crazy at 0, and it would have to oscillate an infinite number of times, which you can't do, right? And so as x approaches 0, this thing just oscillates more and more wildly, and so it never actually approaches a single value, right? And so that would be a non-removable discontinuity. Everybody agree? It'd be a weird one, okay? But with the x out front, that's not the case. You got to kind of think about this now in terms of the scale of these two parts. We've got an x times a cosine of 1 over x squared, right? Cosine of 1 over x squared, even though it's going to oscillate wildly, it's only going to go between -1 and 1, right? What's x doing as x approaches 0? If we took the limit of f of x, okay, we would say that this part, this factor right here, is bounded or contained, right? What's this one doing as x approaches 0? What's that factor doing? It's going to 0, right? So I end up with a product of 0 times some number between -1 and 0. Well, what's 0 times a number that's between -1 and 0? 0, right? And so the overall limit would go to 0, right? And so if I were to graph that thing, what would it look like? Well, I guess as x approaches 0, it's just going to look, I mean, not that you need necessarily to know this, but it's going to look something like this. So it's kind of going to go yeah, it's going to look kind of like something like that, right? Here, and the wavelength is going to get a lot shorter. It's going to get longer as you go further away, right? Yeah. It's going to get longer as you go through. But as you get closer and closer to 0, this thing's going to oscillate faster. But what you're multiplying the cosine function by is going to get smaller, right? And so you do get this discontinuity here. You can't define it at 0, but it's removable, right? It's kind of tricky. Okay. What about something like this? Where are the discontinuities here? Yes, sir.
This wasn't really regarding that, but just in general, if you have two asymptotes approaching infinity, would you have one is that or not?
What do you mean by that?
So like if you have a vertical asymptote of 3, and coming from 3 from the positive side, approaching infinity, coming 2, 3 from the negative side, it's approaching infinity as well.
Okay.
Would your limit be infinity?
Yeah, it'd be infinity. Yeah, it's a good question. Okay, so let me answer Kurt's question first, because that's Kirk's. This is a good. I said Kurt or something. I don't know why I said Kurt. So anyway, here's what Kirk's asking. This is a good question, very good question. So if we had a function that's doing this, let's say, right, and then over here it's doing, let's say it's doing, you tell me if I'm getting this right. I think I am. Very good question. So do we have what's the limit if this is at, let's say this is at 2, and this is out here at, I don't know, like 9, okay? The limit at 2 is, you can't say anything about it. The limit from the left is positive infinity, from the right it's negative infinity. And so you can't, there's no limit, but you can't even say anything consistent about the limit. This one right here, though, the limit from the left and the right are both positive infinity, and so you could say the limit at 9 is infinity, right? right? That make sense?
Okay.
The two-sided limit. Okay? What about this guy? So where are the discontinuities here? So when you identify the places, the x values where this function is discontinuous. Lily, what you got? Tell me, where is this one discontinuous?
Oh.
0 and what?
8.
8, good. Okay, those are the zeros of the denominator, right? If I set the bottom equal to 0, I could just factor that, and I'd get 0 and 8 would be the two zeros of the denominator. So those are my discontinuities, right, for sure. The function can't be defined there, so it has to be discontinuous. Which one is which? Well, how would I know which one's removable and which one's non-removable? What do you think? What am I going to do? Gauge, any ideas what I could do here if I've got the bottom factored? Now, that's how I find my zeros at the bottom. What else would I need to probably do here? Okay. Kirk, what do you think? You find the zeros at the top. So if I factor out an x, then I'm left with x squared minus 6x plus 8. So what am I going to get there? So like x minus 8, no,
2 and 4.
2 and 4, never mind. So I'd have minus 2 and minus 4, right? So then now, you tell me, what's going on at 0, removable or non-removable? Removable, good, because 0 is a factor of the top and the bottom, right? So that's one I can get rid of by just canceling the x's, right? Everybody agree? The 8, though, doesn't cancel, and so this one, that one's non-removable, that one's removable, good.
So is that the only thing that makes it non-removable if it's just in the bottom, or just in the top?
Right, right.
So if it's either one, but not both?
Of the denominator.
Just the denominator?
Right. It's a what we call the unique zero of the denominator. If it's a shared zero of the top and the bottom, then it's a whole, right? It's removable. And the proof of that would be, what if this function, or what if the question said, define a new function that is continuous at 0? All we would do, let's just call it, I don't know, call it g of x, and it would just be x minus 2 times x minus 4 over x minus 8. Right? I would just cancel the x's, and now this is a new function that's only discontinuous at 8. Right? We filled in the hole. Okay? What about this? Find the value of a that makes this function continuous at every x. What would I do? What do you think? Maybe I haven't heard from you. What am I going to do? Who haven't I heard from? Kyla, what do you think? If I want to make this continuous, I got to define a value of a that's going to make it continuous. It's a piecewise function. Emily, you got an idea? Joe?
If you set 2ax equal to 16.
Okay, you can, but it's important that you know why we're doing it, right? Why are we doing that?
To find the value of the derivative of that 16.
What's it? The what?
It's the function.
Okay, so in order for this thing to be continuous, that just means that, think what that means. What does point continuity mean? What are the 3 criteria for point continuity? It's defined, which it is, right? The function is defined when x is 16, right? What else? The limit exists, right? And then the value of the limit equals the value of the function. So the part where we could get tripped up here is, does the limit exist, right? Does the limit exist? Does the limit from the left equal the limit from the right? If not, we're going to have a gap in the function, but we want to choose the value of a So we don't have a gap in the function. So really what we're doing here is in order for this thing to be continuous, the limit of f of x as x approaches 16 from the left just has to equal the limit of f of x as x approaches 16 from the right. We agree? Okay. And what is this? From the left, we just get, if I evaluate this at 16, what do I get? 16 squared is 256 minus 192 is going to be, what, 64? What's the limit from the right as x approaches 16? Well, no, but we don't disregard the a. It's 32a, right? So we got to set the value of the limit so those are equal, right? So a is 2. Okay. Okay, and that's what's going to make those two limits be equal. Okay. Okay, what could I do here? Determine the value of a for which the limit is continuous at -2, right? Because the top part of the function is discontinuous at 2. So what would I do? If I want to know what a is, right? The value of the function, doesn't that mean that the value of the function at a has to equal the limit of the function at a, right? Okay, at -2. So the limit of f of x as x approaches -2 is just the limit of x squared plus 7x plus 10 over x plus 2, right? Well, that's 0 over 0. But I can factor the top and the bottom, and what's the top factor into? Oops. Now I can evaluate directly, and what do I get? 3. Okay. So the limit of the function as x approaches -2 is 3. The value of the function is equal to a. Well, those need to be equal, so what does a need to be? 3. Right? Okay, last one. Find vertical asymptotes and horizontal asymptotes for this. So everybody take a look at this. This one's kind of tricky. I'm going to throw some stuff at you like this. It's not hard. You have to do anything, but you got to be able to interpret what's going on. So horizontal asymptotes and vertical asymptotes. Okay? Vertical asymptotes would occur where? Easy, what do you think?
In the bottoms.
What's that going to be? When? 1. Exactly, right? The only way that the bottom's going to be 0, if I've got hand to the 2/3, well, the only value that's going to make the bottom 0 is 0 to the 2/3, right? So there's what I'm looking at. When is x minus 1 equal to 0? When x is 1, right? And that's not a 0 at the top, is it? Right? If I plug in 1 at the top, I'm going to get something other than, I'm going to get some number other than 0, right? And so that's a vertical asymptote. F of 1 is equal to some number divided by 0, which is a vertical asymptote. Okay? What about horizontal asymptote? That's going to be where x approaches positive or negative infinity, right? We don't care about this because this is a sign is bounded. So that's not an issue, right? What am I left with? I'm left with an x minus 1 to the 2/3, right? And on the top, I've got a 5th root of x. Well, that's the same thing as an x to the 1/5, right? So if I look at the leading term down here inside, it goes like an x to the 2/3, right? X to the 1/5 over x to the 2/3. What's a bigger power of x? Bottom is. So what's the answer then? If the bottom is more powerful than the top, it's going to be 0. Yeah. So the horizontal asymptote at y equals 0. Make sense? Okay. All right.
So when are
We
we
good?
taking the test?
Say it again.
When are we taking the test?
Monday, Tuesday.